I want to give thanks to my Patreon and channel supporters who make this content possible. If you enjoy this episode, please consider supporting the channel to make more content like this possible. The Eurofighter 2000 is a modern multi-role fighter aircraft specialized in interception and air superiority. It is currently in service with Britain, Italy, Germany, Spain, as well as various other nations in Europe and the Middle East. Before we take a closer look, I'm going to make sure that we are all on the same page here. This aircraft goes by a variety of names: Eurofighter, Eurofighter 2000, Eurofighter Typhoon, or simply EF 2000. Britain, who also played a big role in co-developing this bird, simply calls it the Typhoon. No surprise, really. In any case, I'll be using the names interchangeably here in this video. It's the same plane. So, welcome to Military Aviation History. Today we are at the Flugwerft Schleissheim near Munich taking a look at their exhibit. Now, the Eurofighter is a twin-engine Canard delta wing design manufactured by a consortium called Eurofighter Jagdflugzeug GmbH, composed out of EADS, now Airbus Defence and Space, 46%, BAE 33%, and Leonardo 21%. Before we go into all the gizmos, a bit of a meta look. The aircraft is 16 meters in length, has a span of 11 meters and stands at 5.3 meters. Empty, it weighs about 10,000 kilograms and has a maximum takeoff weight of 23,500 kilograms. About 70% of the aircraft is made out of carbon fiber composites, 15% of titanium and aluminium alloys, 12% glass reinforced plastic, and the rest being acrylics. Its low weight, delta wing configuration, high thrust, and canards give the aircraft a great amount of agility, lift, and stability in flight. So let's have a closer look. The aircraft features two Eurojet EJ200 afterburning turbofans developed by Eurojet Turbo GmbH, another consortium created in parallel to the Eurofighter GmbH. As the basis, the Rolls-Royce XP40 was being used. This was also one of the reasons why France split from the project, as they believed that their own engines would probably suit it better. The development in Europe was also carried forward to minimize reliance on US-American jet engines. Each engine weighs about 1 ton, and it has a length of 4 meters and a maximum diameter of 73 centimeters. Each give about 13,000 pounds of thrust or 20,000 pounds with reheat. These engines also give the plane a thrust-to-weight ratio close to 1.2 to 1, which is rather high in a modern jet. They allow the airplane to go to supercruise at Mach 1.5 without reheat and propel the aircraft to a maximum speed with reheat, of course, of around 2,500 kilometers an hour. The Eurofighter has a number of fuel tanks, 2 in each wings, separated perpendicular to the aircraft, as well as 3 internal tanks set in line on top of the fuselage, and a transfer tank. Internally, this gives it a fuel capacity of about 6,000 liters. Additionally, up to 3 drop tanks can of course be carried by the aircraft, each with an additional 1,000 liters. In a standard swing roll configuration, this gives the aircraft a range of about 1,400 kilometers. Here's the eye-catcher of the Typhoon, of course, the canard, or the foreplanes. These are a bit funny because they have both their benefit and their shortcomings. There has to be a lot of testing to get them right. They provide pitch control symmetrically with the flaperons on the wing, the outer flaperons being more important there. Now, the foreplane itself initiates the maneuver, while the outer flaperons trim the aircraft throughout it. With the flight control system, you are set to gain a lot of agility, mainly at subsonic speeds, and the carefree handling system of the Typhoon also prevents the pilot from exceeding the safe envelope, although it does actually give some leeway for overshoots. All in all, you might even say the computer controls the canard, not the pilot, since it will only translate control inputs to a safe or close to safe limit, and never mind how hard you pull, it won't allow you to go beyond that. Well, Britain brought the basis for the engine. Germany, to, well, probably no one's surprise, brought the weapon. The 27mm Mauser BK-27 gas-operated revolver cannon is the same weapon. already featured in the Panavia Tornado, firing a 27 by 145mm shell. Weighing around 100 kilo, the weapon is compact and light in comparison to competitors and supplied with 150 shells. At a rate of fire of 1,700 rounds per minute, it does have a lower rate of fire than some other aircraft's cannons, like for example the 20mm M61 or the 25mm GAU-22. This is compensated for by its half-second burst mass being higher due to the bigger projectiles and also the constant fire rate of the weapon. Ammo adapted to both air-to-air and air-to-ground is of course available. The weapon is notable that it's the first revolver gun to use linkless conveyor belt ammunition feed systems, which reduces stoppages, although this only seems to be actually used in the Eurofighter and the Gripen and not in the Tornado. Beyond this, the jet of course features 13 hardpoints, 8 on the wing and 5 under the fuselage, which are partially recessed, up to a maximum load of 9,000 kilograms. It can use anything from short-range AM-9 Sidewinders or the newer Iris-Ts and the AM-120 AMRAAMs. The Meteor for BVR capability is also being pushed forward. All in all, the air-to-air suite is actually pretty competitive, which is good, because, well, the Typhoon is of course initially meant to fill that role. For air-to-ground capability, the Typhoon carries a general mix of laser-guided bombs, standoff missiles of course, and your general air-to-ground missiles. Next to that, a targeting pod can also be carried in the central hardpoint under the fuselage when the loadout requires it, and more recently anti-shipping missiles are also in the works. Now we're going to do a quick walk around on the Eurofighter here, and I'm going to point out the most important systems and aspects of the aircraft. What we have here though is the DA-1, which was one of the first flyable prototypes of the aircraft. This was used mainly for handling and engine performance testing. Now, there is tranche 1 to 3, upcoming 4 as well, with sub-block in between to actually have the aircraft in operational capacity. But since these are not all shown here, I will be showing out where the various areas and bits and bobs would go. Now, as we move up front, we of course have the radome up front that would hold the Captor radar, which will also recently being upgraded to Captor E. And if we just look up top there, you can't see anything there now, but that's the first piece in the puzzle of DAS, the defensive air subsystem produced by Leonardo. It also goes by the name of Praetorian. And that is the IR laser system warning. Now we of course have the canards here as well. We already spoke about those. And then as we look up to the cockpit, just behind the cockpit, that is also where the air brake features, and it pops out essentially along the spine of the aircraft. As we move along, we also see the variable intake nozzles for the engine. And then as we go to the leading edge, here is another warning system for the defensive air subsystem, and this would here be the missile approach warning system. And it's also mirrored on the other side of the wing, of course, and covers mainly the front area and the side area of the aircraft. What would also be important here on this side is that the Mauser cannon, which feature here, but it's obviously a prototype for engine and handling characteristics where it doesn't feature. Moving along the leading edge, of course, we have a fuel tank just behind it with another fuel tank on the trailing edge, but these are slats, of course, full-on leading edge all the way to the wingtip. We approach one of the hard points with an air-to-air missile. Those, of course, feature heavily in the Eurofighter since it is mainly an interceptor. And as we loop around the wing of the LFU 205, we come to the electronic warfare pod. This is also, again, part of Praetorian or DAS. And on this side, on the starboard wingtip, the electronic warfare pod also has a towed decoy that can be popped out here to essentially help the aircraft evade radar detection. So at the rear of the aircraft, we of course have the outlets for the twin engine setup, a variable nozzle of course in here, and we have the drag chute featuring there. And then below, we also have an arrestor hook on the aircraft. As we swing up to the top, we have the vertical stabilizer and the rudder, and all the way on the top tip of the vertical stabilizer, we would also have your HF, your UHF, and your IFF antennas. Moving along a little bit further there, where you see EADS Defense and Security written, you will also see a little intake. Actually, it's an outlet on the right-hand side. An intake is facing the direction of travel. Back here, roughly in this area, mirrored on either side, will also be the rear missile approach warning system from DAASS. And here we have the inner flaperon of the aircraft. Of course, the tricycle landing gear, you can kind of see it. But what's interesting here as well is these little pylons. Now, they don't feature anything at the moment below the wing. However, chaff would be launched on either side on the outer pylon, whereas on the inner pylon, it would mainly be flares. As we move around then, we have, of course, the outer flaperon as well. And then we come to the electronic countermeasure and surveillance system with the aft antenna right here, and the fore antenna would go right here. And this is sort of the last piece in the puzzle for the protective system that the Eurofighter features. Okay, having come around from the electronic countermeasures and surveillance system, we move along the leading edge of the port wing. We of course have the tricycle landing gear here, the port rear wheel. And as we move along, you will find a missile recessed into the fuselage. This is partially recessed, of course. The Eurofighter features 4 of such hardpoints, and there is a 5th hardpoint just in the middle and along the center line of the fuselage, which is not occupied at the moment. So as we loop around a little bit further, we'll just have a look again at the variable intake nozzles here for both engines. On this side, on the starboard side, you can actually see through the engine, and you also see some markings again that were used for testing. So yeah, that completes our walk around on the Eurofighter. Let's have some concluding thoughts. While it was a slog to get the Eurofighter developed, the consortium of British, Italian, German and Spanish companies eventually made it happen. France had also been a co-developer early on, but it had dropped out in order to carry on development of their own design, the Rafale. Now, beginning work in 1983, the first proof of concept design flew in '86, and in '94, the first real prototype took to the skies. By now, the end of the Cold War and the political differences between the different parties had nearly torpedoed the development multiple times. And it is somewhat slowing down to a crawl at times, only entering service in 2003, 20 years after the project actually started. The initial design anticipated the Typhoon as an air superiority fighter, set to counter aircraft like the Soviet Sukhoi Su-27 flanker or the MiG-29, and to fill a hole in the European air forces. The Eurofighter is, of course, not without its critics, as it does have certain limitations compared to some other planes out there. But that's really quite normal. There's always a give and take with every design, depending on its development and its role. And its development cycle here, of course, with the Eurofighter left room for improvement. But if you take into account the specification and role it was meant to fill, as well as the operational conditions over here in Europe, the Eurofighter does provide a solid answer, albeit an expensive one, of course. What one could argue, however, is that one of the main troubles with the design is that the Eurofighter provides somewhat of a limited value in the multi-role domain it was placed in recently compared to more dedicated machines. With the aging Panavia Tornado fleet, although it is of course expected to fly until 2030 if not longer, the Eurofighter is more and more slotted into this role. So a lot of the recent development work was to remedy this deficiency. I want to thank the Deutsches Museum Flugwerft Schleissheim for giving us access to their Eurofighter. If you want to visit the museum, make sure to check out the information in the description below on their official website for the latest entrance information. If you enjoyed this video, please consider supporting via Patreon or channel memberships to make more of this sort of content possible. It certainly won't be produced by the traditional media. If you can support, don't worry, I understand it. Please consider sharing the video and subscribing. And as always, I wish all of you a great day and see you in the sky.